Welcome. In today's tutorial we will be doing IoT-based solar panel monitoring using Arduino voltage sensor module. We will connect the components needed for this tutorial, assemble them on a breadboard and proceed to programming them with the Arduino IDE. All components needed for this project design can be found in the blog post link in the description below. And so is the Arduino program codes used in the project tutorial. Free to check it out later. We will also design the Blynk IoT Dashboard for this and in the end run a test for the project to see if it works. Without wasting much time, let us begin. We would like you to like and subscribe to our YouTube channel. Also, share and enable notification for future video if you fancy it. We begin with the schematic diagram of the project tutorial. We designed this using the Fritzing Circuit IDE. It allowed us to design it both the circuit stage and breadboard or the pictorial form. The circuit diagram used an Arduino Uno board. You can also opt to use any of the variant family of the Arduino that uses the ATmega328P microcontroller, whether it is the SMD-based type or the THT. Also, the Arduino voltage sensor that can take up to 24 volts DC input. We searched and selected the ESP8266, also known as ESP01 module. We did the connection on both the breadboard view and the schematic view. It began with connected the power rails of the ESP01 to 3.3 volts and ground pins of the Arduino Uno respectively. Then connecting the serial communication pins RX and TX to digital pin 2 and 3 on the Arduino Uno pins respectively. The enable pin of the ESP01 is also connected to 3.3 volts pin. We use different color of wires to denote each connection. The solar panel has already been connected to the Arduino voltage sensor module on parallel connection. The positive wire VCC is connected to the VCC of the voltage sensor while its ground pinout is connected to the ground wire of the solar panel. The other 3 pinout are connected thus, the VCC to 5 volts on the Arduino Uno, the ground pinout to the ground and the D-out pin to the any analog pin on the Arduino Uno board. Let us design the Blynk IoT Dashboard next. This is the place where we get to monitor the project remotely. Go to the Blynk IoT platform. On the right side of the dashboard, click on New Template. And it will open this input boxes where you can put the name of the templates and the purpose you are creating the template for live, a brief description about it template. You get to also select the type of microcontroller board that we are using to send the data to Blynk and what mode, if it is GMS or Wi-Fi method. We chose the ESP8266 board and mode as Wi-Fi. You can opt to add an image to your template, to make it stand out and look more classy. Just click on Add Image as shows on the template info section. It will open up your local directory for you to select or pick the image of your choice. In our own case, we didn't have any befitting image, so we searched the internet for the right image. After a while we ended up finding the right image that fits to be on our IoT template. You can scroll through the remaining sections of the templates to see if the default settings are actually right for you. The metadata column here seem about right, so we left it as it is. On the data stream section though, there isn't any data stream yet. No events has been set either. And there is nothing on the web dashboard. We proceed to adding some on the web dashboard by clicking on Edit. Here we are going to be adding some widgets to our IoT solar panel monitoring dashboard. To get started, we needed a widget that can display or show us the voltage level of the PV panel. To get this done, we used a gauge. The next phase is to edit the widget and make sure it can take the voltage level readings coming from the PV panel. We change the name of the widget, its virtual stream pin, its data type, SI units of measurement, and also set the maximum and minimum range of data it can accept. We equally made a copy of this by creating a chart or histogram widget so that we can track what time the readings are being sent. We can use this widget to keep track of the voltage level over a period of time. It is worthy to mention that the Blynk chart widget doesn't exactly give the expected user experience. Most of these, when done, will appear in the Mi Devices part of the dashboard. And once you are done, you can proceed to the Mi Device section to check it out. Now, we are done creating our IoT dashboard. Let us proceed to assembling the components and connections according to the schematic diagram. The connection is simply basic since it is modeled on a breadboard. We connected the ESP01 to the Arduino Uno board. The connection were done using some male-female jumper wires. We ensured that the connections were tight and firm. Next up is the connection of the Arduino voltage sensor module to the solar panel. This is also pretty basic, as we just had to connect each power rail to the inscribed pin out on the voltage sensor module. are done using the crocodile clips to clamp the wires from the PV panel, we are ready to proceed to testing the project to know if it is going to work. Next up, is programming the project design. This is the Arduino sketch or the source code used for this video tutorial. You can find the link in description below. We used both the Blynk libraries and the ESP01 libraries to make sure we connect to the Blynk server. The rest are JSON modified example of the original Blynk code. It is worth to know that the algorithm for the voltage measurement is the result of the two onboard resistors on the voltage sensor module. Read and find out more on the blog post. To begin testing the project, we uploaded the source code and waited for it to upload finish. Next, pop up the serial monitor and you can use the serial print debug to know if the ESP01 is connected to the assigned Wi-Fi network. As shown on the serial monitor here, we can see that the ESP01 is connected to the network and it has internet access and has already pinged the Blynk server with success. And to verify if the readings measured are what are being sent to our IoT dashboard, we navigate to our device and click on the project and see that we are receiving real-time measured voltage levels of the PV panel. This is how we do the remote monitoring for the project tutorial. IT worked. And that is a wrap for this video. Let us know if there is anything we can do help in the comments section below. Thank you and see you on the next video.